To another installment of Geography 596B. We'll have our capstone presentations here. I'm glad that everyone can join us for a series of what will undoubtedly be a fine set of presentations on a lot of effort that was put forth over the past couple months. So the first up will be Eric Ford. He will be describing a topic on identifying landlocked public parcels. And Eric, at the end, and this applies to all of our presenters, will be having a series of questions from the audience. And if you could read the question before you answer it, that would be great.
Got it.
So take it away.
All right. So yeah, my name is Eric Ford, and this is my capstone project for Geography 596B in the fall of 2020. And the topic is identifying landlocked public land, which is just public land that is not accessible to the public. And before I get started, I'll say that the source data and examples are all from my home state of Nevada, but the same analysis principles would hold true for pretty much any state with a comprehensive land ownership data set. So here's a little overview of what I'm going to be talking about today. We'll talk about the background of how public land came to be and how public land came to be landlocked. Talk about a previous study by the Teddy Roosevelt Conservation Partnership. Go through the objective of this study, talk about the methods I use, and then dive in with the approach, and I'll show the actual process. Talk about some issues identified in the scripting process, and then go over the data sources I ended up using, and then a few constraints for this type of analysis, and then I'll show the results, including a web map. So first, a little bit more about what exactly landlocked public land is. So landlocked public land is land that is managed by a local, state, or federal agency for the public to use, but is not accessible to the public. There are several scenarios where this occurs, but most commonly inaccessible public land is either surrounded by private land or is only touching adjacent public land at a single point. Here are a couple of real-world examples. On the left, this Bureau of Land Management parcel is totally surrounded by private land. This is pretty common, and the only way for the general public to access this parcel without trespassing is to charter a helicopter and fly in. And the example on the right is a little different, but it also is landlocked, even though it's actually touching parcels on both sides. Again, you'd have to charter a helicopter to fly in to avoid trespassing, even though it looks like you could sneak up right into the corner and just step across to the other corner of the BLM land without touching private. This is known as corner crossing and is pretty much illegal in every Western state. So in most Western states, public land makes up a majority of the land area, because historically land that wasn't claimed when the states became states was just put into public trust for the government to manage. And since then, the only really major change came in the 1870s when the railroads were coming through, and the government gave every other section to the railroad as an incentive to build the railroad out to the Pacific Ocean. So as a result, in Nevada, for example, public land still makes up about 77% of the total land area. And because this is because public land is so common, it has become a go-to for outdoor recreation in the West. And pretty much everything outdoor related you can do without the need for permission or a permit or anything. You can just go out and have fun. So another important question is, why is landlocked land such a big deal, since I just got done saying there's no shortage of accessible public land? For example, the Teddy Roosevelt Conservation Partnership estimates that about 2 million acres of public land in Nevada and about 15 million acres across the West is not publicly accessible. In Nevada, those 2 million acres represent about 2% of the total land area. So even though landlocked public land represents a small percentage of the total, it's still a pretty large area. And the reason that this is a big deal is that every landlocked acre represents missed opportunities for public recreation and enjoyment of land that is owned by everybody. These landlocked parcels become an extension of the adjacent private land, but can only be enjoyed by a few people, which is not the purpose of public land. I will say there are several types of access programs that provide incentives for private landowners to allow access across their land, but they're not common in Nevada and are not considered as part of this analysis. I also want to mention that this is not the first of its first study to try and look at landlocked public land. One other really good study is done by the Teddy Roosevelt Conservation Partnership. And it's a really good overview, high level. It talks about why it's important, and it shares numbers for each state. But this is geared towards the general public and not GIS nerds like me. So it didn't have a detailed methodology and didn't have a map of the results. So when I was reading the study, I was wondering, how would I perform this analysis? And that's kind of how this project came about. So the objective of this project is to identify and leverage existing land ownership data to identify landlocked public parcels. To accomplish this, first I developed and implemented an algorithm to identify the landlocked public parcels, and we'll provide a link to the code later in this presentation. Second, the results are the results are provided in an interactive map, so it is easy to zoom in and view the status of individual parcels. To map every landlocked public parcel, I automated the process because there are about 75,000 land features in the Nevada dataset alone. Based on the previous example, it is pretty easy to identify landlocked public parcels visually, but trying to pick all those out of 75,000 would be pretty time consuming, and I'm pretty sure I would make a few mistakes. The obvious solution was to automate the identification process, but this posed some challenges because there are so many variations in the spatial relationship between parcels. My first thought was that the analysis portion would be really easy, and I could just perform the ArcMap near analysis and identify public parcels that are not touching other public parcels. It didn't take long to figure out that the near analysis is not sufficient to determine if a parcel is landlocked because of the corner crossing issue I talked about earlier. Just because a public parcel touches another public parcel does not make it accessible. I did some research and couldn't find any existing automated solutions that are out-of-the-box tools. Thinking about the relationship led me to the solution I automated for this project, which is to compare the perimeter of every public parcel to the length of all coincident edges for all adjacent parcels. If the sum of the lengths of the coincident private parcel edges is equal to the perimeter of the subject public parcel, then it is landlocked. This is kind of abstract, so I have some examples on the next slide that should help explain it. So my algorithm automates the identification process by looping through each public parcel in the entire data set and making a dictionary of the perimeter of each parcel. The dictionary keys are the unique identifier for the parcel, and the value is the perimeter. Then the script compares the perimeter values for each record to the sum of the private lengths for the ArcMap polygon neighbors table. If the length of the perimeter is equal to the length of the private coincident edges, the parcel is considered landlocked, and it is inserted into a new feature class of landlocked parcels. So to do the math here, the example on the left is obviously not landlocked based on the visual inspection. But to step through the math, the script will run. We add up the length of the coincident private edges and compare it to the total perimeter of the subject parcel. In this case, the private length is 380 feet and the perimeter is 400 feet, so the parcel is not landlocked. On the right, the sum of the coincident private edges is 400 feet and the perimeter is 400 feet, so the subject parcel is landlocked. In order to make the results more meaningful, I identified landlocked parcels that are next to public roads or that are in populated areas. The assumption is that even if a public parcel appears landlocked, from the analysis, if a public road runs through it, it would no longer be considered landlocked. This other assumption is that landlocked public parcels in populated areas are likely accessible, but due to identification constraints of the algorithm, they appear landlocked. Examples of these are like public parks, government buildings, and other community open space that is accessible, it's just surrounded by private and shows up as inaccessible in this analysis. And also, instead of automatically excluding these parcels from the analysis, I just added them to the results so that users can see the impact of these decisions in the final project. In order to verify the results, I visually double-checked in a few areas I noted that were pretty complex, and the algorithm handled these areas beautifully. But I didn't want to visually check the whole state, so I ran the near analysis geoprocessing tool using the landlocked public layers and the public parcels as the inputs. And the plan was to check the results, and if there was any parcels that were really close to each other, to convert to a raster for a cost surface analysis. but this didn't occur in the source data. So throughout the process of developing the algorithm and making these results, I ran into a few hiccups, and I'll talk about these here next. So the first issue is the potential for landlocked public parcels to appear accessible if they are touching other landlocked public parcels. This is just due to the math I was talking about earlier. In order to solve this problem, I dissolved the parcels using the ownership type as the dissolve attribute. This way, touching parcels with the same ownership are now one big parcel, and the entire chunk can be classified as either accessible or landlocked using the algorithm I developed. Another issue I ran into was how to accurately identify public roads to include in the analysis. I looked at different road data sets, including the Tiger data, hoping to use county roads maybe, but that didn't work out because there's only 4 counties that share roads. State of Nevada Department of Transportation has some roads, and then OpenStreetMap. OpenStreetMap is by far the most comprehensive, but it doesn't include a public or private attribute. So I didn't use it because of the potential to remove landlocked parcels along private roads. And I verified this using the Washoe County assumed public roads layer. And there was a lot of roads that were private that showed up on the OpenStreetMap. So I used the most comprehensive public data set, which was from NDOT. Finally, another issue was how to determine populated areas. So many of the populated areas in Nevada are either not incorporated or don't share GIS data. So my idea was to run a point density analysis using some input that has some that ties back to population. So I looked at using the Microsoft building outlines that they just published for the entire US, but I ended up using road intersections because I think that captured it a little bit better, but I think either way would have been fine. And the results show, I think, a pretty good representation of the populated areas in Nevada. So here are some constraints that I ran into that all have the potential to lead to an overcount of landlocked public parcels. And these are kind of inherent in the analysis, and I don't know that there's really anything I can do about them on a large scale. The first issue is easements, and easements have the potential to allow legal access across private parcels based on how a parcel is mapped. Mapping and legally certifying easements is a science unto itself, and the company I work for has licensed land surveyors that spend a majority of their time gathering historic parcel records and carefully mapping easements, some that are dating back over 100 years. So given the subsequent liability and difficulty of mapping easements on a single parcel, it is not surprising that there is not a comprehensive statewide easement data set. Like easements, historic access patterns can cause parcels to appear landlocked when they are actually accessible via an unposted road or boundary. For example, historic access can be where an old dirt road crosses private land, but the landowner hasn't put up a gate or posted it with no trespassing signs. Based on experience, this is fairly common in rural areas, but the access can be revoked at any time. So even if these parcels could be identified in the analysis, I think it's safest to assume that they're still landlocked because the owner could change his mind and gate off his road at any time. Finally, the corner crossing issue is important and it keeps coming back and it's becoming more of an issue. And in some states, it sounds like there's potential to change the definition. And since corner crossing is a state issue, different states can have different corner crossing rules. So based on all the unknowns surrounding this analysis assumes that corner crossing is illegal, but could be revisited if it changes over time. So a little bit about my results. Like I said, there's going to be Python code to automate the process and an online map to show the results. So the Python script is set up to work with data from any state that has a public-private parcel database. And in order to share the results in a meaningful way, I didn't want to just shrink the entire data set onto a letter size map and pass that out and say, here you go. So I made a web map that includes the public parcels, roads, and populated areas used for the analysis, as well as landlocked public parcels so users can zoom in and see the status of individual parcels. So here, the Python code is here if anybody wants to look, but I figured I would share a little bit from my web map, which is here. So as I said, you can toggle on and off whether or not these landlocked parcels are near roads or within populated areas. And I think based on all these constraints, my total sum of landlocked area acres is about 1.9 million acres. And if you zoom in, you can start to see the results a little more clearly. The green is the adjacent private land, and the pink is the BLM, landlocked BLM parcels. And this area I'm zooming in, you can see the checkerboard pattern that was created by the railroads in the 1870s, which is still visible today. So finally, my final piece is to compare to the previously published results, and they're both around 2 million acres, mine being about 6% lower than the previously published results, which I think is pretty good validation of both sets of data. And that is all I have. So any questions?
All right, well, thanks a lot, Eric. That was great.
All right.
As we wait for questions, again, Eric, if you see a question in the chat, if you could just read the question before you respond.
Okay. So will they show up in the Zoom meeting, or how do they show
And
up?
if you open up the chat window, that's where the questions will appear. While we're waiting, I have a question for you real quick. So your approach handles the public land survey system quite well. Have you thought about extending that into like the meets and bounds or other survey systems that aren't necessarily rectangular?
Yeah, it does work for pretty much any of the parcels. I don't know if I can zoom in and find one on short notice, but most of these ended up actually being rectangular just because of the section nature of the data. But I think there's some. Yeah, there's a few. I'm not sure I'll be able to zoom into one, but it handles just because it does the perimeter calculation. It handles the funny shaped parcels pretty well. It just is a little more complicated.
All right, good. There are two questions in the chat.
From Eric Sweat, how do you plan on hosting your web map? Yeah, I probably should have mentioned this is in ArcGIS Online, and it's taking advantage of the sort of dashboard template that they have. And I think for now it will continue to live there. I haven't really given any thought to any long-term hosting, although it's on the Penn State ArcGIS Online, so I think that should last for a while. And then second one, what do you think explains most of the difference between the number of parcels acres you found versus previous estimates? I think there's a lot of variability, and I don't know the source data that was used in the other study. So things like if they're using a different, maybe more detailed parcel database, and then things like the roads would probably be the biggest single factor, because if they're using a different road database that has maybe fewer roads, then they would be calculating public parcels that are intersecting roads and not finding the same thing I'm finding. And then he says, also, I would love to see this for Pennsylvania, particularly for areas adjacent to water. It's fishermen here without a boat, so I'm constantly scouting for access. Yeah, I know that's how I feel too, although we have a lot less water in Nevada to worry about. But stream access is another big access issue. Another question is, have you had a chance to do any field validation or share your work with an entity or municipality that may be interested in unlocking these public parcels for use? I've done a lot of field validation and I haven't found any issues so far, but I haven't really reached out to anybody as far as sharing the results, but I think I would like to, and I know a few people in the work for GIS in the counties that would be interested in seeing the results of this. So I'm planning to reach out. I just haven't gotten around to it yet. Another question, can you talk through the perimeter calculation again? I understand the basic idea, but maybe you can go through the details of how you implemented your calculation. Okay, so okay. Swap back here. This is the slide that has the math on it. So basically, the first step is to run the ArcMap Polygon Neighbors tool, which spits out a table that has all the parameters for all touching parcels, and so it's a linked table by object ID. And so from that, I can get the length of all perimeters for a given parcel, and then I'm just comparing that to every parcel in the database based on the common parcel identification number for the parcels. And then the math is just adding up the coincident edges from the polygon neighbors table and comparing that to the length of the perimeter of the subject parcel. And it just happens over and over and over again in the script. It actually takes a couple hours to run. Oh yeah, the polygon neighbors tool is the important part.
All right, well, thanks again, Eric. That was a great job.
All right, thank you.
And you can stop sharing, and Ben,
Stop sharing.
Once he's done, you can get yours set up. All right, so next up then we have Benjamin Dunphy, who is going to give us a talk today on prioritizing areas for Table Mountain pine restoration. Ben, take it away.
Hi, my name is Ben Dunphy. My advisor is Alan Taylor, and for my capstone project, I looked at prioritizing areas for Table Mountain pine restoration. Before I talk about my analyses, I want to share some background information on Table Mountain pine. Table Mountain pine is endemic to the Appalachian Mountains. It prefers poor site conditions within a specific elevation window. It is very shade intolerant and is typically found in very rocky, acidic, and excessively drained soils. While it can be found on sites outside of its natural habitat, those specimens are usually linked to human activities. It is also a fire-dependent species. This is the fruiting cone of the Table Mountain pine, and they are what are called serotinous cones. This means they usually only open after being exposed to heat, which usually comes from a fire. The photo on the left shows an immature cone, while the middle photo shows a mature one. And the photo on the right shows an open cone after a fire is moved through. And these are a series of photos showing Table Mountain pine regeneration after a high severity fire. High severity fires are often called stand replacing fires due to the fact that most of the mature trees are killed. The top left photo shows an area of the Rocky Top Fire in Shenandoah National Park a few weeks after the fire had occurred. The top right photo shows an area of the same fire later in that same calendar year. The bottom left photo shows the same burn area 5 years after the initial fire. And finally, the bottom right photo is from last year. The area now has a mature stand of Table Mountain pine. It was not until the modern era of full suppression that fire has been largely excluded from the landscape. Records indicate that fires were once a commonplace event that occurred every 5 to 15 years in Table Mountain pine stands throughout Appalachia. This leads to the question I'm trying to answer. Where is a suitable location to reintroduce fire to help restore Table Mountain pine? To answer that question, I chose to use Shenandoah National Park as a case study. Shenandoah National Park is located in the Blue Ridge Mountains of Western Virginia. It is a little over 100 miles long and averages about 4 miles wide. It is approximately 308 square miles in size and has roughly 124 miles of federally designated wilderness. The main reason I chose to use Shenandoah as my study area was because Table Mountain pine fills a unique ecological niche within the park's landscape. Also, during my time working at Shenandoah, I served as a wildland firefighter, and I felt that by better understanding where these trees grow and how fire interacts within these ecosystems, I could become a better steward of the land throughout my career. In order to complete this project, I conducted 3 analyses. The first analysis is the replication of a 2011 study to show where the current prescribed burn priority is located in Shenandoah utilizing updated data. Prescribed burning is when fire managers intentionally set an area on fire to meet management and ecological goals. These goals may be, but are not limited to, reducing hazardous fuel loading, to open up the understory, and to promote the growth of fire-dependent species. They are conducted under specific weather conditions and are extensively planned to avoid them escaping their control lines. The second analysis is to locate suitable habitat for table mountain pine in Shenandoah. This analysis is based on the site conditions that are mentioned in literature for table mountain pine. And the third analysis is a table mountain pine habitat burn priority analysis. This analysis utilizes the techniques and data from the first 2 analyses to identify priority areas to reintroduce fire to help restore table mountain pine. The data for each of these analyses were predominantly comprised of raster data sets. For the current prescribed burn priority analysis, the data needed was a fire history layer and a vegetation fire tolerance layer. For the suitable habitat analysis, a digital elevation model, an aspect layer, and a soils layer was needed. And the table mountain pine habitat burn priority analysis utilized the data from the previous 2. Additionally, a landscape compartment layer was utilized to summarize the data. In this case, it was the park search and rescue grids. The landscape compartments in this layer are defined by ridges, stream, trails, and roads. And while they are useful when searching for a missing person, these geographic features are often used to help to stop the spread of wildfires and to define prescribed burn units. This layer was initially used in the 2011 prescribed burn priority study and is the common summary layer between all of the analyses conducted for this study. It will be used to help visually compare the results from each of the analyses and to help identify future project areas. The results of these analyses were several different map products. The first analysis resulted in a prescribed burn priority map summarized by landscape compartment. The second analysis resulted in a habitat suitability map. And the third analysis resulted in a table mountain pine habitat burn priority map. And each of these maps can be used to better understand where table mountain pine could be located and where future projects could occur to restore table mountain pine to its natural habitat. The intent of the current prescribed burn priority analysis was to identify areas where prescribed burning could meet management goals and still be beneficial to the landscape as a whole if park managers were to conduct a prescribed burn today. The current prescribed burn priority analysis was conducted utilizing a weighted overlay, and it used the fire history data and the fire tolerance data as input. The weights were based off of the initial study conducted in 2011, and each layer was given an equal weight, and the different variables in each layer were given different priority values. The fire history layer was prioritized based on the year since an area last burned. Areas that are between 5 to 15 years since last burn are prioritized with a value of 9 because they are within the time window to have a fire pass through again. Areas that were burned more than 15 years ago were given a priority value of 5 since they are past their reburn window and the ecological benefits might not be as great if the area was still within that window. Areas that were burned less than 5 years ago were prioritized as a 1 since they have not yet reached that reburn window. The fire tolerance layer was prioritized so that the highest tolerance vegetation communities were given a priority of 9 and the lowest tolerance a priority of 1. The resulting output raster dataset was converted to a shapefile, and the data was summarized by the landscape compartment layer using the Summarize Within tool in ArcGIS Pro. As you can see with these maps, there are relatively few high priority compartments in relation to the number of landscape compartments throughout the park. This is due to the fire history layer, and it predominantly reflects where fires have occurred in the past. The suitable habitat analysis was conducted using a raster overlay approach and assumes that all of the input layers are weighted equally. The map algebra tool was used to find areas of overlap in each of the input data layers. Initially, I selected a 1 meter DEM for this analysis because I had access to the data, and the terrain in Shenandoah can vary over relatively short distances. However, after reading the documentation for the fire tolerance layer, I chose to reclassify the DEM to 17 meters to keep the resolution consistent throughout the scope of this project. Using this DEM, I created a habitat elevation window and an aspect layer for the overlay analysis. Also, since Table Mountain Pine prefers specific soil conditions, I exported the excessively and somewhat excessively drained soils from the initial soils dataset and converted them into a raster dataset for this analysis. The output from this analysis represents the potential habitat locations for Table Mountain Pine. The data was summarized using the landscape compartment layer so that it could be compared to the current prescribed burn priority map. One benefit of the fire tolerance layer used for the current prescribed burn priority analysis was that the modeled landscape classification data was ground truth for accuracy. When looking at the accuracy assessment plots for the landscape classification used, there are plots that confirm that some of the areas identified as potential habitat are in fact Table Mountain Pine habitat. From these two analyses, it was hard to tell where prescribed burning would benefit Table Mountain Pine ecologically just by looking at the mapped results. The third analysis really addresses where is a suitable location to reintroduce fire to help restore Table Mountain Pine. In order to determine an approach to answer the research question, I looked at the data and the analysis techniques for both of the two previous analyses. When reviewing the report written for the 2011 study, they referenced a study conducted at Eglin Air Force Base in Florida, where a weighted overlay was used to prioritize prescribed burning locations so that fire was introduced to all areas of the base within 15 years. After reading that paper and looking into their approach, I determined that a weighted overlay was a better choice than a simple overlay analysis for this part of the project. This approach allowed me to prioritize the input data based on what I found to be most important for the growth of Table Mountain Pine from the literature. Since the weights for the overlay analysis can greatly affect the results, it was important to think about what would be the most important layers. Since this analysis was used to answer the research question, I determined that I need to create a weighting scheme that prioritized Table Mountain Pine habitat. I knew from my readings that Table Mountain Pine prefers warm and dry site conditions and that aspect played a major role for the location of Table Mountain Pine habitat. The southwest aspect is the warmest and driest microclimate within the landscape, and so these areas got the highest weight. I also knew from looking at the fire tolerance data that the only forest type prioritized as high priority in the current prescribed burn priority analysis happens to be the forest type which contains Table Mountain Pine. Since this layer represents where Table Mountain Pine could possibly be located in the landscape, I chose to assign it a weight towards the top. Since this analysis was also attempting to locate areas where fire should be reintroduced for habitat restoration, I chose to weight the fire history layer as the third highest value. To allow for comparison between the results of this analysis and the current prescribed burn priority analysis, I chose to keep the time since last burn priority values the same as in the 2011 study. Though it seemed to be the limiting factor in the suitable habitat analysis, based on the literature, the soil type did not seem as important as aspect when it came to suitable habitat. This was primarily due to the fact that Table Mountain Pine is known to grow outside of its natural range as a horticultural specimen and in areas of human disturbance. Unlike the previous two analyses, a landscape position layer was included in this analysis. It was derived by using a tool from the University of California, Davis called the LMU Toolbox, which classifies landscapes into 6 different slope categories. It was used in this analysis as a way to give some priority to ridgetop areas. It was not given a high weight because during the classification, the ridgetop areas do combine both southwest and northeast slope components. And from the literature, it is known that Table Mountain pine really naturally only grows on southwest slopes. And finally, elevation was given the smallest weight. This is mostly due to the fact that a majority of the park falls within the habitat elevation window, but it was included because there are a few places within the park that are not in that window. The results of this analysis show where prescribed burning may be beneficial for Table Mountain pine and the ecosystem as a whole to maintain the 5 to 15-year fire regime. Most of the potential habitat that would be suitable for prescribed burning is located in the southern end of the park. This was most likely due to the location of suitable soil and the location of past fires in the park. One of the questions that was brought up after my capstone proposal presentation and after looking at the literature again was, what effect does the weighting scheme have on the results of the data? In order to better understand this, I conducted a crude sensitivity analysis of the input data layers. To accomplish this, I varied the weights of the input data. When developing the new weighting schemes, I tried to keep the weights proportional to their initial weights. The only 2 layers that I chose not to do a low weighting scheme for were the aspect layer and the fire tolerance layer, since these 2 layers were critical for identifying Table Mountain pine habitat. When looking at the results from the sensitivity analysis, there was little change in the overall geographical location of much of the high priority areas. However, by varying the weights of the input data, there was a change in the total area of the top 3 priority classes for these areas. After looking at the sensitivity analysis results, one thing was clear: the fire history data had a big impact on the results of the weighted overlay. This was likely caused by areas weighted in the fire history layer that are not within the 5 to 15-year reburn window, lowering the resulting weights of areas identified as potential habitat. By lowering the input weight of the fire history layer, the results better represent overall potential for Table Mountain pine habitat. Based on this, I chose to run an additional weighted overlay where I removed the fire history data completely. This resulted in a map where habitat is prioritized based on ideal site conditions and the current presence of Table Mountain pine in the landscape. The difference in the results of these 2 weighted overlays from a prescribed burn perspective would be the fire severity used to facilitate restoration efforts. The results from the weighted overlay with the fire history data included could indicate areas where a lower severity reoccurring fire could be utilized to open the serotinous cones and create a receptive seedbed, since Table Mountain pine might be occurring naturally in these areas due to an active fire regime. And areas identified in the weighted overlay without fire history data could indicate areas where a higher severity prescribed fire may be needed to reintroduce Table Mountain pine, since forest succession has taken place, which could be due to the exclusion of fire from the area due to wildfire suppression over the years. And while it may be hard to see, as a parting image, I want to show the potential habitat throughout Table Mountain pine's natural range, which has helped to reaffirm that this analytical process is not just limited to a small geographic area, but can be utilized throughout the region and anywhere there is a fire-dependent ecosystem. I will now open it up to questions.
All right, great job, Ben. As the questions come up in the chat window, if you could just read out the question before you answer. And we'll have time for 1 or 2 questions before we have to move along.
So from Ryan, I'm curious if there is a reason to not using the fire history layer as a mask to simply exclude the areas outside the time window rather than using it as an input layer in the weighted overlay. Yeah, so the fire history layer, that was a key component in the initial prescribed burn study. And so the Park Service can actually get more money, and it's easier to justify the prescribed burn if they are doing it within the natural reburn window. And so by including that information, it kind of helps justify certain areas. And since the fires aren't naturally limited to the landscape compartment, it just helps to kind of build a bigger picture of where they could add more fire or connect parcels together to create a larger fire rather than just excluding them altogether.
All right. If you have other questions and would like to talk a bit more with Ben about his study, you can head on over to the Slack conversation. Anthony posted the link to that channel over there, and you can carry on the conversation. Right now, I'd like to move forward with our next presenter, Eric Sweat, who will be talking to us about binary logistic regression analysis of sanitary sewer overflows in Beaver Ruin. And we can see your screen, Eric, so you're ready to go.
Thank you, Fritz. Well, good afternoon to everyone on the East Coast, and good morning to those on the West Coast, and good day to all of those in the middle, in the Midwest. As Fritz said, I'm going to be talking about sanitary sewer overflows. Fritz was actually my advisor, so thank you for that, Fritz. I'll be talking about my regression analysis of Beaver Ruin sewer basin and the sewer overflows. Quick overview. I'll do a brief introduction about sanitary sewer overflows, provide a bit of background, the purpose for my research, a little bit on previous research on the topic, methodology I went through and the results I received, and talk about my next steps. So what is a sanitary sewer overflow? Well, essentially, it's when there's a blockage in the county maintained system that causes the sewage to overflow. A typical layout for a residential home, for instance, will have a private sewer lateral with some cleanouts. It'll connect to the public system, where if there is a blockage or an obstruction, it'll cause that to overflow, like shown in the picture on the left. As a public service announcement, please do not put things down your drain or in the toilet that don't belong. We follow the 3 Ps, pee, poop, and paper products, approved paper products, please. And thank you. So I'll be talking about Gwinnett County, Georgia. We're right outside of Metro Atlanta. 437 square miles. It's fairly large and very populated, the second most populated county in the state. And we have approximately 178,000 sewer connections in our system. The system is quite large with over 3,000 miles of pipe. The lighter shaded area on the map that you see on the right are septic tank areas, so we don't have sewer coverage on those parts of the county. And in addition, there's around 82,000 sewer structures for us to maintain as well, so a very large sewer system. We also maintain 219 pump stations, and which essentially gets the sewage to our 3 wastewater treatment facilities, where collectively we treat approximately 58 million gallons of wastewater per day. So for this project, I wanted to figure out which basins are more likely to experience an overflow. So what was really nice was to be able to group these sewer overflows by basin and plot them on the map here. So we have about 18 sewer sheds. So it was really easy to see where we have most of our problems. So that was great. The other thing I wanted to look at was, well, which basin should we focus more of our maintenance? So that was really good to do this visual assessment. Currently, we prioritize our maintenance based on known pipe material. It was thought that certain pipe materials cause sewage to, or solids to back up, roots to come into the line a little different. So we've historically targeted everything based on pipe material and haven't seen much change. So the purpose was to go through this data exploration exercise to determine the relationship between the occurrence of a sanitary sewer overflow and a number of independent factors that we see throughout the sewer system. So I wanted to single out which independent factors contribute the most to these SSOs, and then map the location of these factors. That way we can target our maintenance in these specific areas. 3,100 miles of pipe is a lot of pipe to clean. So it's great to be able to identify smaller areas. So that's the basic gist of the project. So the EPA publishes all sorts of documentation for utilities and provide guidance, but they don't really get into specifics of a sewer system. They speak very generically. They walk through sewer modeling, how to determine where you might have problems based on rainfall, where you should be, or different practices you should follow for proper inspection and maintenance. But again, it's very generic and it's got a very wide audience, so it doesn't get specific into any one sewer system, for instance. There's been other studies where regression analysis has been used to help answer some questions. I've found a lot of literature on linear regression, which is helpful when your variables are continuous throughout the system. For instance, like rainfall is continuous throughout the county or during a rainfall event, but the occurrence of an overflow is not continuous. So I chose to do a binary regression, which basically predicts the occurrence of an overflow or not having an overflow. So essentially a 1 or a 0 is the results of the analysis. Have an overflow, don't have an overflow. So that's what I wanted to find out. The first step was to pick the study area. As the title says, I'm looking at the Beaver Ruin Basin. It had the most overflows. And just to clarify, these are not annual numbers. This is reviewing approximately 7 years of sewer data. So fortunately, we don't have overflows occurring like this every year, but this is a 7-year time window. So I selected this area. It had approximately 200 overflow events in that 7-year window. The next thing I did was identify the variables I was going to use for the regression. So I had to take some time to look through my the data I had available. The next step was to classify the sewer pipe network. This was something that was mentioned, and we typically do not classify our sewer network similar to streams. If folks are familiar with the Strahler stream ordering, we just classify our pipes based on diameter, material, and things like that. So I went through the steps to classify the sewer system based on stream ordering, which was pretty interesting. The next part was to format the data. Not all the data was numeric, so I had to categorize and transform some of the data to work with the regression. And the last step was to go through a series of binary logistic regression analyses using SPSS, which is an IBM product. So the first, well, what's my dependent variable? Well, it was the occurrence of an SSO. So that is my dependent variable here. The other independent variables I chose, 2 of them were nominal, so they were categories. So the pipe material, which is, again, that was the assumption we've gone with this entire time, is to target maintenance on certain pipes. On the left here, you can see the results of my stream ordering classification. So as pipes converge and have, for instance, a first order stream come through and converge into a second stream order, and the second stream order pipes converge into a third order stream, so on and so forth throughout the sewer network. Typically in stream systems, that typically means as the tributaries or streams converge in a watershed, they become larger. In our sewer system, that's not necessarily the case. Primarily, all of our piping you see here in the second, third order streams are all going to be 8-inch diameter sewer, which is our minimum diameter. Some of the other variables I chose were age, the slope of the pipe, and some of the flow data we receive from our sewer model, the average flow and the maximum, like what we would call our peak flow. I did not use pipe diameter. Again, a bulk of our pipe is all the same diameter. There wasn't much variation. Not until we get to the larger, in this case, the 7th stream order. Whoops. Here, this is our larger transmission mains that get the sewage to the sewer treatment plants or large regional pump stations. So we don't experience overflows in these areas. The pipes are very large. So I'm going to walk you through the 4 different analyses I did with the SPS software. I first started small. I wanted to see how the model would work in a smaller area. So I chose the top minor service area in Beaver Ruin. It's the BR02 sub-basin. And briefly to describe, we categorize or divide up our sewer shed into smaller basins, and we monitor those with sewer flow meters to gauge and measure the amount of flow we receive. So in this particular Beaver Ruin basin, we have approximately 21 minor sewer basins. It's fairly small, but here you can see the results of the stream ordering. It pretty much stair steps with the number of pipes you'll see as a first order stream or a first order pipe, second, third, and fourth. This particular basin only had a small amount of 7th order streams or pipes due to that large transmission main. So one of the discussions I had and had to do some research on was what size data set should I go with? 20 unique records out of about 700 was a pretty small data set. There was some research talking about a good rule of thumb to apply, and they had this equation. So if you take 50 plus 8 times the number of your variables, that will give you a large enough data set to use. So I chose to select a larger set of pipes that did not experience an overflow and compare it to those 20 pipes that did as an unbalanced data set. The method I used, it was called the inter method. It essentially throws all the variables in at once into one model, the kitchen sink approach, if you will, and it'll gauge which factors or variables are significant when it creates the model. The second analysis I did was in the same exact area, except for this time I chose a balanced data set. Again, the total data size was still pretty small at just 40 records, but it helped compare, I think, tried to see if it would help compare apples to apples a little bit better. Again, it was the same method, which includes all the variables into one model. So being concerned about the size of the model or not having enough records, I chose, again, the top 10 sewer basins in Beaver Ruin, and they accounted for more than half of all the occurrences. So I had 123 unique pipes that had an SSO. And again, here you can see that this data set is much larger, with thousands of pipes. And again, seeing that same stair step breakdown between first order streams, second order streams, et cetera. Since the data set was large enough, I felt comfortable going ahead to do a balanced data set to pick 123 pipes that did not experience an overflow to get a very large data set. Again, I threw everything into one equation just to see what would come out on the other side. The fourth and final method was using the same data set, again, the larger balanced data set at 246 pipes. Except for the method I chose was a little different. So in SPSS, there's different methods I could apply to the regression. And I chose this forward likelihood ratio method. Essentially adds and removes variables based on significance. So as it steps through, it can create one or many models. The previous methods just created one model with everything in one equation. So this helped determine which variables would be significant and could potentially create multiple models to look at. So SPSS gives a lot of information in the results. I'm going to briefly touch on 3 of the outputs for each of these analyses to walk through the significance of the model. One of the first values the model or the software will spit out is a Hosmer and Limachow test, which basically tests the statistical significance of the model itself. The first run was the smaller data set with 20 SSOs and around 98, I believe, pipes that didn't experience an SSO. And the model was great. It came out, it was statistically significant. So what did the model predict? Well, it didn't do such a great job at actually predicting an overflow at all. It did a fantastic job of not predicting an overflow. I believe a good bit of this was due to the fact that I loaded the data set with a bunch of pipes that didn't experience an overflow. So the model just did not do a great job. It was 83% accurate overall, but it was spot on with not predicting an overflow. So that didn't really help me out with what I was looking for. The last output I'll discuss in these analyses are the results of the variables. So here it'll show the statistical significance of each variable in the equation. And as we can see, there was no variable identified to be any statistically significant at all. So this was kind of a letdown. However, I had 3 more methods to apply. The very next one was the balanced data set with 40 pipes, 20 with an overflow and 20 without. That Hosmer-Limachow test showed the model was not statistically significant at all, which means taking the results with a grain of salt, I guess. So the model did better at predicting. The overall accuracy, I would say, was worse. It was only 75% accurate, but the model actually started predicting overflows as opposed to not predicting overflows. So that was great. So it predicted 13 of the 20 having an overflow, and then it also predicted 3 of the 20 pipes that didn't have an overflow, but it predicted they would have had an overflow in the model. So that overall accuracy was 75%. Again, the model wasn't significant. None of the variables were significant. So throw those results out and move on. So the third analysis, again, was what I call the top 10 balanced. So I took the top 10 overflows with a balanced data set. And lo and behold, the model was not significant again. And the model did a little worse, again, overall 68% with its prediction accuracy. Here are the results as it predicted pipes not having an overflow at 65%, pipes experiencing an overflow at 71.5%. So it didn't really, again, do that great. The model wasn't significant, but lo and behold, we finally had I saw a variable that was determined to be statistically significant, and that was the age of the pipe, which is a little bit surprising. Each duration, the pipe material, nothing stood out. Again, that was the method we've been applying all this time for maintenance. So not statistically significant with pipe material. So the next method was the forward likelihood ratio. So what this did is actually step through 3 different models as opposed to just one. In the first model, the statistical significance was great, less than 0.1 at a 0.065. The second model was even better, less than 0.05. The third model, however, was not statistically significant. So the software basically stopped. But okay, we ran the third model with the variables in the equation. It was no longer statistically significant, and it stopped adding variables. So each of the models has its own accuracy percentage. Model 1 at 59.8% accurate. Maybe a little easier to read here. At 59.8% accurate. And again, that model was statistically significant, less than 0.1 at 0.65. The second model, the overall accuracy of the model was 58.5% accurate and was the most statistically significant at 0.012. The third model, again, the model was not significant, and it did actually a little bit better at predicting at 62.2%. The other item that the results identified was age was the first variable identified at being statistically significant at 0, which was great. And again, it was identified in the previous inter method as being statistically significant. So that wasn't a surprise to see. What was surprising was seeing the third order stream classification being identified as being significant. So the second model just used age and used third order streams to have the result or the statistical significance of that model being that 0.012. The third variable it added that was determined to be statistically significant was the slope of the pipe, which would makes a little bit of sense to me. However, when it was added to the equation, the model itself was not significant, so throw it out. So I was really interested to see the results in model 2. So I essentially went backwards again to compare and validate the results in analysis 4. So I took that second model, and I took the variables to enter them in manually and I received that significance of 0.012. I received the same exact percentage in the model, and that was using only the age and third order stream segments in the inter method. So just to recap, after I went through the 4 different analyses, the forward likelihood ratio method was great at giving me the variables that were statistically significant, which generated a model that was statistically significant. And then I could take those values and plug them in and see the results of that. So real quick, the results. So I could see the stream ordering, the stair step didn't apply. So I'm seeing more third order streams experiencing an SSO than would be expected. And here is a location of where these SSOs occurred. A lot of the older stream segments experienced overflows, which also makes sense. And here is the location of those SSOs by stream order. The next part I did was hide the model or hide the basins that I did the model on, and I reran it on the other basins in Beaver Ruin and see how it did. And I saw similar results. Third order streams were still more third order streams experience overflows than would be expected normally based on the normal distribution of the stream ordering. And here's the location of those overflows by the stream order. So next steps is to target our maintenance on third order stream segments with age greater than 29 years. Evaluating the effectiveness may take years because it'll take time for us to clean and evaluate whether or not we experienced less overflows over time. And then as I guess an additional step, I'm going to take a look at another basin, the Patterson Basin next, and apply that forward likelihood ratio method to that specific basin and see what results come out of that. Then I can target maintenance on those pipes and hopefully get into a good maintenance cycle. So with that, I would like to thank everyone for attending. Fritz, thank you for all your help, and Beth for all the frantic emails when I'm trying to navigate signing up for class and things. And my employer, Gwinnett County, for being super supportive. And of course, I'd like to thank my family. They have their dad back now that I've completed my project and not have to worry about school for right now. So thank you for your time.
Okay, thanks, Eric, for the thorough discussion of your results. We're running a little bit behind on our time. I know there were a couple of questions posted in the chat. I think it'd be great if you could carry that conversation over into Slack. There was the Slack channel that was put up by Anthony. I know there's some conversations that are going on there right now. I'd like to move on with our presenters, if that would be okay. So next up, Dominic Gaetano, if you could get your slides ready to go. All right. Today, Dominic is going to be giving a presentation on Out of Harm's Way, creating a storm surge and mobility vulnerability index. So Dominic, whenever you're ready, please take it away.
All right, thank you very much. Can everybody hear me okay?
Yep, you're good.
Yep.
Perfect. Yes, my name is Dominic Gaetano, and my capstone project is entitled Out of Harm's Way, Creating a Storm Surge Immobility Vulnerability Index. And before I get started, I want to thank my advisor, Helen Greatrex, for all her support from when this project was just an idea to what the final project is right now. So thank you very much, Helen, for all your hard work and all your guidance and support. We all know Florida is susceptible to hurricanes. Since 1851, 120 hurricanes have hit the state, resulting in hundreds of billions of dollars in damage and thousands of fatalities. The leading cause of damage and death from hurricanes is storm surge. Storm surge is the abnormal rise in water level above the normal tide. Winds from a landfalling tropical cyclone pushes a massive quantity of water onshore. Wind waves travel on top of the surge, which allows even more water to make its way inland. A cubic yard of water weighs over 1,700 pounds, which can easily destroy structures and infrastructure. Storm surge accounts for about 49% of all hurricane-related fatalities. The risk of death due to storm surge and the overwhelming power of moving water means that evacuation is the best means of preserving life in areas where storm surge is likely. One of the most challenging tasks facing anyone in an emergency management capacity involves managing the mass migration of people in a populated area away from danger. Imagine you are a county emergency manager with limited resources and time. You need to manage the evacuation of what possibly could be millions of people from a heavily populated area. And while many of those people will leave in their own vehicles, many others will not have that luxury. Physical and financial limitations may make it impossible for people to evacuate on their own. Picture yourself as one of these people who must evacuate. You probably own your own vehicle, and you could cover the cost of food, fuel, and lodging even if you have to charge these expenses. You have the information you need to plan an evacuation route and have a destination in mind with information you gathered through a smartphone or computer. Now imagine you don't have a smartphone or enough cash for gas and lodging. Perhaps you don't even own a car. This would leave you immobile and totally reliant on assistance in order to evacuate. Your immobility will leave you vulnerable, and vulnerability will be an important term going forward. There's no one generally accepted definition of vulnerability, and many studies into the topic define the term to suit their body of work. But ultimately, most of these definitions define three principles: people, exposure, and some type of risk, whether natural or man-made. There have been no shortage of studies on environmental hazards, vulnerability, or the evacuation of people. However, research that combines all three has been a bit difficult to find. Some of the most prolific research into vulnerability involves the Social Vulnerability Index, or SOVI, as a way to quantify vulnerability. Developed in 2003 by Susan Cutter, SOVI is a model designed to comparatively quantify vulnerability over a given area. The index combines factors such as race, gender, employment, income, and others, 27 in all, to calculate relative vulnerability. The data is obtained from the American Community Survey and can be scaled from the local to national level within a state, county, or census tract level of resolution. Areas with high or low vulnerability are those that lie within 1 standard deviation above or below the mean. One of the downsides of SOVI is that the vulnerability of an area could change depending on the size of the study area. At the county level, a given census tract could have low vulnerability, but if you expand the study area to several counties or the whole state, the vulnerability for that tract could become moderate or high. SOVI is also hazard agnostic, which can be a benefit or a drawback. It doesn't take into account any one particular hazard, but in reality, there are places where natural or man-made hazards are just more common than others. Using SOVI for inspiration, I sought to create an index with a targeted scope on a person's inability to evacuate from storm surge. I chose 5 factors that I felt were the most common cause of immobility and that had demographic data available at the census tract level. And these factors are households with an income less than 125% of the poverty level, households with 0 vehicles, households with no smartphones or personal computers, households with no residents who speak English fluently, and people who suffer from an ambulatory, visual, or cognitive disability. Recall that our definition from vulnerability earlier involves a group of people. And for this project, I chose the people that live in the counties of Broward and Miami-Dade County in southeastern Florida. Like SOVI, the demographic data I used for Ivy came from the American Community Survey, and in this case, it was the 2018 5-year survey. The percent of households or people that meet each of the criteria was used to assign an immobility value of 1 to 5 for each factor, with 5 being the highest and 1 being the lowest. All of these factor indices were summed and an average taken to produce the final Ivy. Percent of households was used, and percent of people were also used as the criteria to assign the individual factor, since many of the households, many tracts vary from tract to tract by thousands of people and thousands of households. So that was why I wanted to go by percentage rather than raw numbers. So we have people, exposure, and now we need a hazard. For this project, the hazard is storm surge from landfalling tropical cyclones. The NOAA slosh model was used to model and map storm surge inundation. This is an active model used by National Weather Service meteorologists and emergency managers alike. Any tract that touched a flooded cell would be selected for analysis. The ACS data was trimmed to match the slosh model output such that any tract that would see any inundation at all would be included in the analysis. And the numerical value of Ivy was then converted to a categorical value. The trimming and merging of data sets, along with the calculation of Ivy, was performed for category 1, 3, and 5 storms for both Broward and Miami-Dade County. Fortunately, the combination of ArcMap Model Builder and some Python tweaks meant that I was able to automate much of the data processing. And that also means that the data could be converted for other areas as well, other counties. The results from my analysis on Ivy were published as both a story map and as a dashboard, all on ArcGIS Online. In the story map, I discussed vulnerability, SOVI, storm surge, and evacuation, and how these factors played into the development of Ivy. The complete analysis was published as a dashboard. And once again, Ivy values were calculated for categories 1, 3, and 5 storms for both Miami-Dade and Broward County. The interactive map features include all attributes used in the calculation of Ivy for each tract, along with indicators and gauges to reflect the average value of each attribute for the entire inundation area. Let's take a tour of some of the results of the analysis and show how Ivy can show how people can be vulnerable in different ways. So this is our study area, Broward and Dade County, and we will start with Broward County. This is the Ivy analysis for Broward County. Census tracts in the shades of green are low vulnerability, while census tracts in orange and red have higher vulnerability. Broward County is a low-lying county where the average elevation is only about 6 feet. I'd like to zoom into one particular tract to the north. This is census tract 308.01 that has high vulnerability. And if I click on this tract, we can see the different attributes that led to this rating of high. You can see over roughly half of the households make 125% or less of the poverty level. More than half make less than $35K a year. And more than a quarter of households do not have anybody who speaks English fluently. And roughly a quarter of the households do not own a computer or a smartphone. So when you talk about a vulnerable area due to immobility, this is sort of the benchmark. Let's move a little bit further to the east. We'll head on out to the coast. This is Census Tract 312.03. And if I click on that, you can see that the immobility index here is medium, even though the mean household income is over $115,000. There are low rates of poverty here. A vast majority of the households here have somebody who can speak English fluently. Most homes own a vehicle, and most homes also have a smartphone or a PC. However, this particular census tract has a high incidence of people with physical difficulties, particularly ambulatory difficulties, which may impede their ability to leave on their own. And we'll take a look at one tract in particular that Ivy maybe didn't show the entire story. This is Census Tract 1002.02. It too has medium vulnerability, even though the mean household income is just over $40,000, and more than a third of households live in below 125% of the poverty line. And even though more than a quarter of the households here do not have anybody who lives there that can speak English fluently, the immobility index is only medium here. And that's because the percent of people with physical difficulties is so low, it's less than 2% for ambulatory, cognitive, and visual. If you compare that to the adjacent census tract, where even though the mean household income is higher and the percent of people that live in poverty is lower, because people have higher instances of physical difficulties, this census tract is given a high, whereas this one is given just a immobility index of medium. And we'll take a brief look at data for Miami-Dade County, or yes, Miami-Dade County. Miami-Dade County is the most populated county in the state of Florida, but it's also somewhat infamous for a vast income inequality. There are two areas of interest that I'd like to explore. One is South Beach, and the other are the neighborhoods of Brickell and the Roads. We'll start with South Beach. This is Census Tract 45. It covers the southern tip of Miami Beach, and it also includes the luxurious Fisher Island, home to the highest income zip code in the country. As you can see, this has a medium-high level of immobility. It's important to note at this point that location, in terms of what your average storm surge amount would be, is not taken into account. So even though some of these areas have low vulnerability despite being right on the coast, the depth of storm surge doesn't take into account into Ivy just yet. As you can see, the level of poverty is about 9.6%. However, this area has medium-high vulnerability because more than roughly just short of a quarter of households do not own a vehicle, and just short of a quarter of households do not have a fluent English speaker. And there's one more area. I mentioned income inequality a bit earlier. These are two adjacent tracts, 6601 here in red and 6702 here in green, separated by Southwest 3rd Avenue. If I look at Census Tract 66.01, this has high immobility. And that's because this is a census tract that has a lot of people with physical difficulties, ambulatory, cognitive. I think that's the highest cognitive for Miami-Dade County. Over 40% of households do not have fluent English speakers, and more than a fifth of households do not own a computer or a smartphone. If I compare and contrast that to Census Tract 67.02, that's just across Southwest 3rd Avenue, you can see the mean income is quite a bit higher. Levels of poverty are just a little bit lower, but the biggest change are the people with physical difficulties. These are low values of low percentage of population with physical difficulties. And also a vast majority of homes have fluent English speakers, a vast majority of homes have a vehicle, and virtually all homes own a computer or a smartphone. And I wanted to compare SOBI to Ivy in order to make a direct comparison. Categorical ratings were converted into integers, and then the difference between the integers were taken to determine where SOBI and Ivy agree, and more importantly, where they do not. There were a total of 463 census tracts in the study, and of these, over 83% of those tracts had an Ivy within one category of SOBI. SOBI did reveal higher vulnerability in Dade County, while Ivy had higher vulnerability in Broward. The biggest discrepancies occurred in Dade County further from the coast. You can see here these areas in orange and red where SOBI had higher vulnerability than Ivy did. And the belief is that this occurred because these areas tend to have fewer zero vehicle homes and lower rates of physical difficulties, which underrepresented Ivy. Now, how could we make Ivy more robust? What can we do to Ivy? Can we add more factors, more demographic factors? Could we add storm surge depth into the category, into the calculation? Other calculations such as distance to highways or the number of storm shelters in the particular tract, possibly weighting some of these factors. None of these factors are weighted because there's no, I don't have the background to say which factor is more important than the others. So none of these individual indices were weighted in the final calculation. Is there a way to validate it? And if so, perhaps there could be a weighting factor to be included in there. In short, how could we make it more useful? So to conclude, I've created a vulnerability index called Ivy to identify areas where the inability to evacuate could put people in an increased risk of loss of life. If you'd like to explore the data behind Ivy, the story map and dashboard are available in the links in the chat. I'll put the links in there as soon as we're done here. And if you have any questions, I'd be more than happy to answer them. Thank you.
All right, well, great job. Thank you for that very, very interesting presentation. So we'll wait here if we have some questions, and it looks like one question's popped up in the chat. So if you could read the question and respond, that'd be great.
Oh yes, James, it would be nice if you could color code the variables presented in your web app pop-up windows to make it clear at a glance which of the variables contribute to vulnerability. This is not talking about necessarily a legend. This is about which areas had the highest vulnerability. Like, what was this a tract because it was a problem? The leading cause of immobility was a lack of vehicles or a lack of a lower income. I considered trying to do that, trying to color code it, but to do it for all, I'd have to find an automated way to do it, some way through code. To do that. Otherwise, I'd have to do it manually for 437 census tracts, which would be difficult to do. The dashboard actually does include the average value for the entire county for each category. And if you give me 1 second here, I'll bring it up very quickly. And from there, you could probably kind of get that information there from the dashboard. Mandy Klein asks, have you thought about using this in other areas? New Orleans, for example. Absolutely. And that's one of the benefits of this is you could replace the ACS data for Miami and Fort Lauderdale, for Miami-Dade and Broward County with the Tampa Bay area, which is actually where this project initially started from, was Tampa Bay. Or you can expand it to Houston, Galveston, or any coastal area, so long as there's slush data, which there will be for all the tropical areas, and as long as there's ACS data, which there certainly is. Stephen Matthews, you may have mentioned it and I missed it, but did you determine data at a different scale? So modifiable aerial unit problem effects. There appear to be some spatial clustering in the maps implying some other scale effects. This is one of the tricky things about SOBI. And it was something that I'd seen in some of the research into SOBI. Let's say you take a county in Southern California and you apply SOBI to that county and it shows medium vulnerability. And then you expand the scope to include, let's say, the whole southwest of the US. And that county's vulnerability could change from medium to low. And then if you expand it again to the entire country, suddenly that county has medium vulnerability again. How valuable is this information if this information is changing just based on the change in scale and scope of your analysis?
All right. Well, great job, Dominic. Why don't we move along here? We're running a little bit behind, but we're doing pretty good so far. Next up, I'd like to introduce Tyler Pilarczyk. He will be talking to us today about assessing wildfire vulnerability in Los Angeles County. So Tyler, when you're ready, please go ahead.
Sure thing. You folks can hear me and see my screen okay?
Yes, we can.
Perfect. Well, thanks everyone. My name is Tyler Pilarczyk, and as what was just mentioned, the focus of my project was assessing wildfire vulnerability within Los Angeles County. Now, wildfires are obviously a huge problem within LA, within California, and as we saw this year throughout the entire West Coast. And I always refer to this list because it amazes me how often it's changing. Now, these are the top 20 largest wildfires recorded in California's history since 1932. 17 of these were within the last 20 years. 9 of these were within the last 3 years. 6 of these were within 2020 alone. So, you know, that's certainly the hockey stick curve that we don't like to see, right? But it's something that we need to deal with as climate change is going to bring warmer temperatures and population is going to continue to grow. We can really expect this trend to really continue. So the objective of the project was to leverage advanced spatial technology to determine both historical and wildfire vulnerability in real time across Los Angeles County. And to do that, I first had to identify the physical and social factors that contribute to vulnerability. I then had to ingest real-time information that helps us determine vulnerability at any given moment. And then we're going to wrap up this workflow into a series of geoprocessing models that can be shared and used by other users that can perform this assessment specifically in LA County. Although if you have your own inputs and your own criteria, you should be able to perform that assessment wherever it is needed. So we can turn to this fire triangle to understand what a fire needs to start, commence, and thrive. In terms of wildfires, that fuel, part of the fire triangle, is usually going to be dried up landscape. So this is going to be prime fuel for wildfires. And the oxygen and heat, of course, are provided by weather patterns. Now, there's some other factors that really contribute to how dangerous a wildfire can get. One of those is going to be wind. And as we experience here in California, that with strong winds, either blow down power lines or they push vegetation towards power lines. It can start a fire in a bunch of different ways, whether it's sparking the line, or it could be bringing down the power line, the transformer breaks, and all the oil leaks out. Those are huge oil drums, and that can really be its own source of fuel for wildfires. On the other side of things, this is where topology becomes fairly important because the wind can bring in greater levels of oxygen by removing humidity. But topology is important, especially in LA, because areas with steep slopes are likely the mountainous regions, and they are covered in essentially prime fuel for wildfires. And plus, because of different pressures in the air during the day, the wind likes to travel up the slope. It's heavier air at the bottom, lighter air on the top, it moves up. At night, it switches, so it wants to go back down. So there's constantly wind going up and down slope, and that's why it really makes these sloped areas in these mountainous regions very vulnerable to wildfires. We can also take a look at the social impacts to vulnerability. We can look at populations that are vulnerable to fires before the event, during the event, and after the event. We can also look at social impacts in terms of the cause of these wildfires. 90% of wildfires have a social or are caused by humans. So we can look into that and see how we can limit that. Now, assessing vulnerability is not a brand new thing in the GIS space. This is a map I found last night, but Esri has shared their wildfire potential layer that we see here for the US for some time now. And they've also started to look into some of these social factors that determine vulnerability and finding areas within California that are especially vulnerable due to their populations. Now, a couple of things to note here. Now, they assessed vulnerability at a national scale. There's no real set standard for vulnerability. It's really defined by whoever is assessing it. So in LA, we may assess vulnerability differently than we would do for the entire country. And the same for social vulnerability as well. It's also worth mentioning that this assessment was done using historical data. So if somehow we drop to 30 degrees and start snowing, this assessment really doesn't mean anything, right? It's a good historical view. Typically, what are the conditions for vulnerability? But we know that the real-time conditions really contribute to how vulnerable an area is to a wildfire. So how do we determine real-time wildfire vulnerability today? Well, really, most of us rely on this guy, right? We drive down the highway, we pass down the sign that Smokey tells us that it's a high fire danger today, and only you can prevent forest fires. So with all the technology we have and all the data that's available, including data on real-time conditions, we should be able to improve this a bit more. And that's really what the challenge of this project was. Not to say that no one's doing this today, but that's something that I wanted to take on for this project. So I'm going to go through the first part of the model, which assesses the physical vulnerability using more static features. And I'll go through these quickly just for sake of time. It looks at landscape. Is it a flammable land cover classification? Is it shrub, forest, brush, or is it urban, rocky? Is it water? And so on. We also look at digital elevation models because that's going to give us an idea of the slope. And the topology, that's so important. We can also look at aspect. So in the Northern Hemisphere, those slopes that are those landscapes that face south get the most sun exposure. So if you have vegetative landscape that's sloped, that's facing the sun, you can imagine that that's going to be very vulnerable. Historically, we can also look at where we've experienced the greatest intensity of winds. Like we said, wind's very important for assessing vulnerability. We can also look at human impacts. Where do people tend to reside and could cause fires? In this case, I brought in some trails and some campsites to help us look into that. And then on the flip side of it, we can also look at fire stations across the county and surrounding areas. And I ran a drive time buffer analysis to see how quickly a fire or where can a fire truck get on site within 15 minutes. So those areas are not going to be as vulnerable as other remote areas that don't have a lot of accessibility by fire crews. When we combine all of those factors together, we get a vulnerability assessment that looks like this. So the model that was used to do this not only combines the features, but also allows the user to define a criteria. So they can determine how much do we value slope, how much do we value aspect, campsites, trails, fire station buffers, and wind. So based off the user's definition of vulnerability, we'll generate the results that the model is going to show here. And because we're working with local data sets, it's going to be a bit more granular and probably more accurate than maybe some of the national extent assessments that were made. So that's one positive of it. And then I brought in fire perimeters over the fires that have occurred in California over the last 20 years. And those that were within Southern California, 95% of those areas were within an area that was classified as vulnerable within this assessment. And that 5% was really those urban areas that are typically, they're vulnerable because they're so close to a landscape that's highly vulnerable. They don't have the landscape for it, but that doesn't mean they're not vulnerable. So let's start diving into the other results of the model. So part of that workflow will also select those census tracts that were within an area that was deemed as vulnerable or directly adjacent to a highly vulnerable area. So on the top left, we can see the tracts by vulnerability score. Bottom left is our percentage of area. And then in the main map here, we're looking at those vulnerable populations that are either limited on resources or aren't aware of the local dangers that wildfires present. And those populations in general are going to be either minority populations that historically have been neglected in emergency mitigation plans as a whole, not just for wildfires. So we have to make sure those populations are attended to. Non-English speakers, especially in Southern California, are key because there's going to be a language barrier. So even if we're trying to educate the public, we have to make sure we're reaching everyone within California and all the languages that are spoken there. And then those without below college education. Some other data set I wanted to bring in was to represent transient populations because they are less inclined to be aware of local dangers. They're not from here. They don't have family here. They may be here for a job. If a wildfire happens, they really don't know what to do. So those folks really need attention. And so one way we looked at that is by renters as well. So that's one way we're looking at transient populations. Now that we're looking at historical assessment of vulnerability, we can start bringing in some real-time conditions. And a lot of these layers are going to be pulled from Esri's Living Atlas. And that's a big part of this model, is that it used mainly all publicly available data sets if you're an Esri user. So it should be very accessible and possible to be used by a bunch of different municipalities. So this is the wind speed forecast that we're experiencing right now. This is the precipitation. Like I mentioned, if we get if we get tons of rain, it's pouring rain in Los Angeles, consider ourselves not vulnerable to wildfires at that moment. Now, the Living Atlas also provides weather station data. Now, it's not going to get that continuous polygon features that we saw before, but we can use it to interpolate it. Now, in this case, I worked with a partner of Esri's called DTN that provides a much more robust set of weather station data. And we took the temperature readings and humidity to be able to interpolate temperature values. So this was around right before I shared my screen. So right now in California, it's still pretty mild. We're actually experiencing some really nice temperatures compared to even 2 weeks ago. And if we look at humidity, it's also going to be fairly humid. And usually in Southern California, when it gets hotter, it removes moisture from the air. So it doesn't surprise me that we have a lot of humidity. So now we're bringing in all these real-time conditions. We can start to see how the real-time analysis works. So on the left, we have our static version that was just created before. And then I used that same model to create the basis of the real-time analysis. So the only difference between, or the two differences between the one on the left and the one on the right is that the one on the right doesn't consider wind, historical wind, because we have a real-time layer that tells us that. It also grades the score or lowers it by a half because we're going to use the real-time conditions to give us the real-time score. We're going to have that factor a lot more than we would have in the previous analysis. So we ran this I ran this analysis last Monday, and we can see the interpolation of temperature on that day where we hit the 90s in this dark red area. This was around 4 o'clock too, so which is really when it's going to get the hottest and driest. This lighter orange area is going to be 80, 70, 60, and so on. So we could look at temperature. We can look at wind as well. For this particular day, I think the most we had was a moderate breeze, which is not going to do much. It's not going to blow down power lines. It's not going to accelerate wildfires tremendously. And then we looked at humidity. And this is where I saw that we had, obviously, coastal areas, urban areas are going to be more humid, but as you get more inland, they get drier and drier. Now, when we combine all of those factors together, the model also has some logic. So temperature, wind, and humidity are all important, but it's not always going to be a positive correlation. So if it's 115 degrees here like it was a couple months ago, and we have really low humidity, we don't need wind to start a fire. And kind of on the flip side, we can have a 75, 85 degree day or 80 degree day, but if it's dry and windy, we are going to be very vulnerable to fires. So with that logic included, this is going to be what our real-time assessment looks like. And a couple things to point out, we can see that the areas that are further inland, like this area in particular, it's going to have the highest vulnerability because of the temperature. And we don't see as high vulnerability in these areas that we saw historically because we didn't have that much wind today. So part of the real-time assessment is also looking at the social impacts in real time. And those ones highlighted in yellow is the same map as before, but now we can see which tracks were selected within this assessment compared to the original one. Now we can see there's actually tracks that we may have neglected in the first vulnerability assessment. For real-time analysis and response, we also have to look at immobile populations. It could be seniors, could be people with disabilities, people that do not have a vehicle or rely on public transit. Could also be children because they don't have the means to really evacuate quickly. And then from here, we can look at the dominant mobile population. So in the mountains, a lot of it's going to be senior citizens, but there are folks with disabilities and children, some other ones. If we look more closer to downtown, we have more of those people that don't have a lot of transit options. Now, one thing with real-time data is that you collect enough of it, it becomes big data that you can analyze. So in this last map here, we're looking at tracks that were selected multiple times over the course of a week when we ran this analysis. So you can see which of those tracks were selected multiple times and the strength of their vulnerability. So to try to wrap up quickly here, I performed that real-time analysis over the course of a week, and I have my nice little smoky meter that tells us the average vulnerability, which is 5.5, but it goes up to 6, right? You can't just put a general value for it because it's going to vary based off where you're at in LA County. So we can start to see over the course of the week, temperatures are dropping, humidity is rising, so therefore our score gets really low. And then by the end of the week, it's looking like we're getting a little bit more moderate level of vulnerability because we're back in the 70s, still a little high in humidity, at least for LA. Now, part of the model, I wanted to make sure I tested it on severe conditions. So I took those readings from the first day here, and then I added the degrees by 15, and I dropped the humidity by probably about a third or so. And this is what it looked like here. So the model does respect higher temperatures and lower humidity. And like in that example too, I also did another test that looked at 80-degree weather, but lower humidity and stronger wind. And you can see that it's just about as vulnerable as if it was a hot, dry, non-windy day. And that's important that the model respects that. I know I'm going quickly here, but I got one more example, and that's post-fire. So how do we know who's vulnerable after the fire? Well, anyone that's within the fire perimeter boundary that lives there, that works there, has children that go to school there, obviously are going to be directly impacted. So we took a graph of all the quote unquote vulnerable populations within this area, within the perimeter itself. We see that actually, a lot of these people that live in this mountainous area, they're, I think they call them comfortable nesters, meaning they had children, they moved out of the house, they moved up to some nice cabins up in the mountains. So really the greatest population impacted are those that are used to staying up there for throughout the entire day. But of course, when you have that much fire and that's creating all that smoke, it's going to blow down to other areas across the county. So now we're going to look at the county as a whole and start to identify those senior populations, those with existing disabilities, and those with asthma, or at least invested in asthma medication that could be vulnerable to the smoke that's caused by the fire. So that's what we're seeing here. And the map is showing us the ratio between population and medical facilities. And that's going to tell us essentially how easily accessible medical facilities are. And if the darker areas are going to be areas with not a lot of medical facilities. So we have to make sure those people are attended to. So I know that was a lot of information. I'd like to continue the discussion in the Slack and maybe answer any questions that you folks may have.
All right, thanks, Tyler. Great job. And we'll look for a question or two to show up in the chat window. And then remember, if the question does show up, if you could please read the question first before answering, that'd be appreciated. I loved your Smokey the Bear score. That's great. That's great.
Yeah. Felt it was worth the time to take it that level. So I'm glad you enjoyed it.
Oh yeah. Yeah. No, that's great.
Okay, so here's one question that's coming in. What do you think about the potential for integrating mobility data from sources like SafeGraph? How it might work? How might that work or not? I think that's a great question. So I think the SafeGraph data that's being referred to is essentially cellular data. And even though it won't contain like all the information that the provider has, you can get an idea of human movement and as well as where people are dwelling at that moment. So I think that's a good question about real-time assessment is where are people at right now? And there are demographics about daytime population. But of course, that information is collected over the last few years. 2020 is a completely different story. A lot of people are working from home, so that's going to be looking a lot different. I actually love the idea of including that data within the scope of this kind of analysis. So I think that's a really great idea to think about it that way.
Again, Tyler, great job and the interest in moving forward and trying to wrap things up here on time. If you could stop sharing your screen, and Mandy, if you could share yours. So next up, we have Mandy Klein, who's going to give us a presentation on network of resources for a child service nonprofit in the St. Louis area. So Mandy, when you're ready, please take it away.
Thank you. Can you hear me okay?
Yes, we can.
Awesome. So good afternoon. My name is Mandy Klein, as he just introduced, and I'm going to be talking about a network of childhood resources in the St. Louis area. I'm going to be using a Tableau story, which has a few dynamic dashboards put together. So an overview of some of the things I'm going to cover today: background, motivating question problem, the available data, data formatting and cleaning, and then going through the story, and then hopefully time for questions. So background of what I was thinking about. My motivation is my son, who's pictured on the right as a newborn almost 7 years ago. And I remember one of the late nights reading about an organization called Nurses for Newborns and their work to try to help parents with newborn babies and young children under, I believe it's the age of 2, to get resources and how they help them to learn how to take care of their children and helping with vaccinations. And one of the things I thought of for my capstone project would be to create a dashboard of resources for nurses for newborns and similar entities, as well as parents who are looking for these resources. And this dashboard is available, this story is actually available to everyone. It's on the Tableau public site. So who, what, when, where, why care? Well, children are the future of this country. They're the future of the world. So I can find my look at the county of St. Louis and the city of St. Louis. They are 2 separate things. I was looking at geographic information of childcare facilities, hospitals, vaccine for children program locations, and government services. Put them on the map and got what I provided whatever attribution information was available from the sites that I got the data from. And then I used a street space map showing relevant landmarks to assist everyone with where am I, what's nearby, where is this along the street, and things of that nature. The data on the background slide or background dashboard is more of background of certain indicators that I found data for the city and for the county over time. And, are they getting better or are they getting worse? So to assist people in using the dashboards, I created a user guide to work through of how do you navigate this entire story, how do you navigate the features that are inherent to a story, and then how do you navigate each of the dashboards and use them in the best possible way, understanding that it is a truly dynamic dashboard capable of having pop-ups and being manipulated by a visitor, going through the different filters, what are they, what is contained therein, going to the facilities dashboard, which is kind of the main focus of the story, but going through and walking through tips on how to use it, an expected feature of if you turn off any of the filters, it will go to a blank screen. That's normal because you can't display 0 within the Tableau environment. And then as you go through different filtering options, definitions of some of the facilities and childcare facilities, and then an image of the different references. For this presentation, I got available retrieved data from a lot of public sites, a lot of Missouri state sites like the Department of Social Services provided a lot of background materials and data. Missouri Census Data Center provided information on kids enrolled in preschools or pre-K, daycares. Missouri Department of Health and Senior Services provided a tabular listing of childcare facilities and all different kinds of childcare facilities, most specifically, and as well as vaccine providers. And that was just a address listing. And then Kids Count from the Annie E. Casey Foundation provided background metrics as well. And then the MDIS, Missouri Spatial Data Information Services open data site from the University of Missouri, the geography department most specifically provided GIS data for hospitals, federally qualified health centers, and the WIC, Women, Infants, and Children program offices. And I should say that the tabular data was literally, I was copying and pasting from the website, bringing it into Excel, helping to get it cleaned out. I had somebody help me to programmatically format it in a way. I took it to the Census Bureau geocoder to locate it on a map. So here is the background data, and sometimes there's a little latency using Tableau on the www, which I'm not used to doing quite yet. So here is the background data. In the future, I'd like to have it a little bit more streamlined and get the different variables from the different sources to work together. But at the top here is a dynamic filter for geographic area. And if I want to choose either the city or the county, right now it displays both sets of data, but if I just want to look at the county of St. Louis right now, I just click on that and it will take a second and it will update all of those graphs to show just the county of St. Louis. And you can have choices for this graphic right here for this display. It will change to have one of the variables. I put them all together because they're all from the Missouri Department of Social Services, as well as they're all related specifically to newborn crisis assessment. Over here are the kids count variables from the Annie E. Casey Foundation. And there are several of them, and you can click off of any number of them. And if you give it a second, it will regenerate them. And if you hover over them, each of the graphics, it'll tell you what is the variable name, the year for it, as well as what the quantity is. So in this case, it's number of children under 6 in poverty in Missouri for the year 2014, as well as the number of children. This one is a percentage of children who are underinsured within the county of St. Louis on a given year. And then these are counts at the top of unsubstantiated and substantiated claims of abuse, whereas this is the percentage saying of substantiated versus unsubstantiated. This is where the use of the hover pop-up boxes is very good, and people can take a look at it and find out what do all of those pieces of information show. Now, this last tab is for the facilities, and this is the main focus of my dashboard. This provides all different types of filters over here on the top right-hand side of different facilities within the St. Louis city and county. There's a wildcard search here on a facility name. If you remember, okay, I know this child care facility I want to look for, it starts with kinder, but you can't remember the rest of it, you can put that in there and it will search for that. And here is a table listing all of the child care facilities. It has hospitals, it has WIC office locations, it has vaccine providers for children program locations, and those different buckets of data are within the facility type. So I'd like to walk through 2 or 3 examples of the capabilities of this dashboard and how it might be used, and looking at it as, okay, I live in the 63021 zip code. So expectedly it flashed to nothing because there's nothing there. So there are the list of childcare providers within 63021, but I'm going to tell it I only want the childcare providers in 63021. And I know I work early, so I want a place that opens relatively early. And I know sometimes my work requires me to stay a little bit later. So I'm gonna want the flexibility of, let's say, 9 p.m. So the nice thing is now I have a list of 5 places in the area that I can go to and look at. And interestingly enough, one of the facilities, Hope Montessori, my son actually attended as an infant until he was 2 years old. So another example is, okay, I work down in the city. I'm going to give it a second to catch up. And I work in the 63118 area code. So I'm going to clear that selection. I'm going to come back in. It's going to go blank, which is an expected result. So 63118. And I'm going to come over here and I'm going to use this feature on the map that allows me to search down to the zip code level. Unfortunately, it doesn't allow for the street. But I work down here in the Anheuser-Busch area of St. Louis. So I'm going to zoom out a little bit. And there are the facilities in the area. So I would, again, would like to have a child care facility. That's what I'm focused on here. And, you know, as an example, I would like to be able to put my 6-week-old baby, and I have, in this example, a 12-year-old kid. So I want to look for, you know, an age limit of 13, just so that we can grow with that facility a little bit more. And, you know, it comes back with one result, which is this little precious angels childcare limited liability company. And the pop-up, you can see that there's the address, the full address, the phone number, the open and close times, and then the age range that that facility will support or will accept. So another feature that you can have down here is staying with looking at the zip code where I work, turn all of the, let's see here, have all of them on. Sorry, I only want childcare facilities, and I'm not concerned with the type of facility that it is. And I know I approximately work in this area. So what I want to do is I want to circle and I want to search within a mile of the facility that I work on and see what facilities are there. Well, I see there's a number of actual facilities, and then there are 2 people who have either an in-home daycare, or they have a registered family home daycare that they're willing to watch people. And I can see here's the age range, here is the capacity for the facility. So I know, oh, well, this is a big facility. I don't know that I'm comfortable having my kid in something, you know, that has so many kids. Well, 10 sounds like a good number. So you have these 2 right here that you can pick from and decide to contact them, because a lot of the times there's normally contact information. There are some times where they don't provide contact information. I did learn through the course of working on this project that there are occasions where there were childcare providers that were eliminated, were not included on the list, and I'm not sure, they were too close to my house, including the facility I dropped my son off at this morning for his e-learning facilitation, so I know it exists. You know, future improvements would be to go back through and find out what happened to some of the facilities that disappeared, you know, from their listing of the state site, or did it disappear in between there? Try to get more information about the hours. Right now, the hour filters, the sliders, only give you the exact range you're talking about. So if you put in 6 a.m. to 9 p.m., it's only looking at facilities that are open those specific hours, not in between. Try to complete the data, get more information, you know, do they have specific, you know, how are their child to teacher ratios? Try to get more information on the healthcare facilities. Right now, I have their names most of the time and their addresses, and sometimes there's phone numbers, and occasionally they provide hours of operation, but not always. The vaccine providers for children, that was only a listing of addresses, and sometimes the addresses weren't valid, that you couldn't find them, and not having a name of this facility made them impossible to locate, to go back and get more information. Also more background data on the different data sets, and more variables for the background data would be nice in the future. And also another potential improvement or future plan would be to expand the geographic area of this project from St. Louis City and St. Louis County to the greater metro area, to include potentially the state of Illinois, not being entirely sure how their information is provided, if it's provided. Any questions? That is everything.
Okay, thanks a lot, Mandy. That was a great presentation. Your dashboard is very, very data rich.
Oh, thank you.
So as questions come into the chat window, again, if you could just repeat the question before you answer it, that'd be great.
Will do.
Maybe you could answer one quick question here before the questions start coming in on the chat windows.
Sure.
How do you see this as what you create as being like a community outreach project?
Well, I would like to provide it to Nurses for Newborn and potentially other nonprofit service-oriented programs within the area. I know that there is more than just them. I've going through the Nurses for Newborn site, I know that they are allied with a network of resources, both here in the city and in the county, but outside of there as well. So I would like to present this to them, potentially to the communities themselves. This is something that, you know, people who are trying to find reliable daycare or daycare in their area can go to this and access this information. Here it's in a geographic format, whereas the state site where I pulled the child care information from didn't have a map, which was very, very frustrating. It was hard to understand, where is this facility located?
Yeah, that's a real good point. Looks like you have a question in the chat window.
Based on your local understanding of this area, what do you think you see if you had more info from across the river into Illinois? I know that childcare is a little bit different over there. After talking with friends over the years of how the differences are handled in the different daycare settings. I know cost is very, very different, and that would be a variable I would love to have, because I know cost of daycare is one of the big factors, besides size of the facility and philosophy of the facility, is one of the big key indicators for parents of this is what I'm going to choose is cost. I would be interested to see the distribution of the in-home daycares versus facilities versus the, license exempt facilities. I know throughout St. Louis, they all seem to be rather equally distributed, although there was a little bit of a higher registered family home. It was a little more concentrated in areas that seem to have, I think it was lower income. So it would be interesting to see how that reflects into the East St. Louis area, given that there's a lot of poverty in that area, and are people more likely to use an in-home daycare because it can be cheaper.
All right. I think we are at the end of the presentation. So I'd like to thank all of our presenters, all the questions and comments and participation from the audience. I hope everyone enjoys the rest of their day, the rest of the week. And thanks again, everyone, for presenting.